Hello everyone, my name is Sumaya and today I will talk about best practices for hardening Microsoft SQL Server against SQL injection. So today we will talk briefly about how SQL injection works and then we will dive in deep about what's the defense method for preventing SQL injection and what's best practices to follow to hardening the system against this injection. So So SQL Server is a Microsoft version of a relational database management system. In 2016, Microsoft started to add security features to SQL Server to prevent against SQL injections. So what makes SQL injection such a common attack and one of the top 10 OWASP attacks on the web applications? Uh, Actually, there are two reasons why SQL injection is such a common and effective attack. First of all, it's relatively easy to perform. And second, it's the attractiveness of the target, which is the database here, because it usually contains such a critical and sensitive information about the organization or about the web applications. So how SQL injection actually works? So usually in web application, we need some input from the users. And the attacker take advantage of this by inserting some SQL command to be executed and change the logic of the program execution. The data that is never meant to be executed. And potentially the attacker can access and modify this data. For example, he can drop a table in the database or can add a column or any other information that he wants. Okay, so what kind of methodology the best practices, the best coding practices to perform to prevent against such attack? So we will discuss 5 of them today, which is parameterized queries, use of stored procedures, whitelist input validation, enforce least privilege, and segregate data. It's recommended that we use most of these or all of them whenever possible to have defense in depth. So if the attacker can bypass one of them, he hopefully cannot bypass all of them. And the goal of all these defense is that to help the developer to either stop using dynamic SQL queries or to prevent user supplies input which contain malicious SQL from affecting the logic of executed query. So starting by the first one, parameterized queries. For SQL injection to be, so what makes SQL injection successful? What makes SQL injection successful is that the program cannot distinguish between data and SQL command. So we used prepare statement. Excuse me. So we use prepare statement to make the program distinguish between these two. So we use prepare statement with variable binding to make the input be treated as a literal value instead of an executable code. And here we have an example. The first example is vulnerable to SQL injection, where the users can input anything here, and the SQL command, the query will just be executed. So if you have any SQL command here, it will be executed. In the second example, whatever the user have input, it will be treated as string. It will be treated as parameter, as a literal value. So even if he has SQL command in here, it won't be executed. The second one is stored procedures. Stored procedure is prepared SQL command that can be saved and reused. And this is actually similar to the first method. It's similar in a way that it has the same effectiveness in preventing SQL injection. But it differs, so stored procedure is different than prepared statements in a way that stored procedure is defined and stored in the database itself, and it's called from the application. And here we have an example. So first we create a stored procedure. That name selected all student, and it takes the name of the student, which defined here to have only 20 characters. And then we have the queries, and then we execute it. So it's not executed directly from the user input. And it's recommended to use a parameter and SB execute SQL, which also known as forced statement catching, which allow the statement to be parameterized. The third methods we have is sanitization, which is identify a legitimate user input. And I want to talk first about whitelisting and blacklisting. Of course, we can use blacklisting to filter, for example, binary data, escape sequence, and comment character. But this is not recommended for two reasons. First of all, we have too many characters that can be malicious, and it's just not possible to define all of them to be filtered. Second of all, if we try to do so, we will have a lot of false positive. So it's better to have a whitelisting where we can define the length and the format of the input, and we can limit a specific use. We can have limit for user input. Also, it's recommended, like we do kind of pen testing before we before we launch any update or web application. In terms of that, we evaluate the behavior of the web application. So we input some kind of malicious attack of malicious code or unexpected input to see how the web application react, and based on that result we can modify or filters our code. Also, we should use input validation in combination with the previous two methods, which is parameterized queries and stored procedures. The fifth method we have here is limiting the access and assign least privilege possible. So let's say we have 100 accounts. If we can determine that account X and Y have only the privilege to drop and add tables, if the others 98 accounts have a successful SQL injection, they won't be able to drop the table, even if they have SQL injection successful. So having least privilege will help to mitigate the risk and mitigate the damage. So least privilege for each account, and then grant access only as needed. So if the users only need to read some information, we shouldn't give them the privilege to write some of the information. And if the users only need to read part of the database, we shouldn't let them read all the database. So set policies and access right, control the access is crucial for database. Also restrict the privilege for operating system account that the database management system hosted in. And it's recommended that we don't assign a database administration account, just because if the attacker have an access or can compromise the database, if he can control the database administration account, he can cause a real damage to the database. Last thing, we have segregating data based on the security it needs. So we always have sensitive information and top secret information that we don't want the attacker to get into. So it's better to save these informations in a resources that it's not in a different network and that it's not accessible, it's not publicly accessible by the attacker. So even if the attacker compromises the system, he or she won't be able to expose and modify the data that considered to be most sensitive and top secrets for the organization or for the web application. Also, auditing and logging will help to detect attack and recover from it. Here we have general best practices that it's not specifically related to SQL injection, but will make our system more secure. First of all, if the attacker could, for example, drop a table, and if we didn't have a backup, that will be a real problem. So we always wanted to have an updated and encrypted a database backup that it's not accessible by everyone. And if we have unwanted users that have an access for the backup, we should change our access control. Also, and this is specifically for Microsoft SQL Server, it's recommended to use Windows authentication instead of SQL Server authentication mode, just because Windows authentication use encryption message and that makes it more secure. And also, disabling unused feature in SQL Server will limit the attack surfaces for the attacker. Also, using a different port other than the default port for the database will not make our system secure, of course, but it will make it harder for the attacker to find the port. He can find it eventually, but that will make him take longer time. And always use complex unique passwords. We don't want to reuse the same passwords. For example, if we have two databases, one of them for like a top secret information and the second one is for less sensitive information, we don't want to use the same password for both. So it's crucial to reuse. It's crucial not to reuse passwords for different components in the system, and to always use complex passwords. So today we talked about SQL injection and how to harden our system against SQL injections using a couple methods for best practices to prevent SQL injection for Microsoft SQL Server. Thank you so much.